right, well, while we're getting started here and Johnny's getting set up, I've got a couple of giveaways, but there's going to be a bit of a quiz that goes along with it. So, do you guys know who has the lowest power cellular device on the market today?
Nordic.
I already have one of these.
Do you? All right. Yeah, thank you. All right, who was the other? There was another. Who else answered that question? What company has the leadership in BLE audio? Anybody know? Huh? You guys are pretty smart. So that's 2 dev kits, so you can do the audio streaming back and forth. Awesome. All right. Who has the world's largest market share in BLE? All right. Who has BLE, Wi-Fi, cellular, all on a unified platform for development? You guys are so good. You guys are so good. Who has? Got another question? I'm running out of questions.
Who has a full out-of-the-box Matter solution that you could develop today? Yeah.
You good? Sure. There we go. Something around that.
Yeah. So, who has a low-cost power analysis tool that works on any SOC?
Nordic.
Yeah.
I've got one.
Who's missing something?
I'll take it. Is that a PPK?
Yeah.
Oh, can I switch?
There we go. All right. Thanks for joining us. I think that was I'm just going to let you take it from here. You know,
Yeah.
So,
Sure.
This is Johnny. He's our applications engineer based in Seattle. I'm Scott, based in Seattle. And we also, you guys may have met the rockstar Pete back there from doing all the stuff for the treasure hunt. And then Kurt in the back, he runs all of our kind of West Coast operations. I work for Kurt. He's based here in Portland as well. So we're here to help any questions you guys have, but I'll turn it over to Johnny.
Sure. So, a couple of quick questions. How many of you, before coming to the show, were familiar with Nordic? Show of hands. Okay. And how many of you were familiar with, who weren't familiar with Nordic, were familiar with ESP32? All right. How many of you who weren't familiar with Nordic are also aware and know well Adafruit and their Bluetooth and Feather solution? Okay. So fun fact, the Adafruit, Bluefruit, as well as their Feather are Nordic designs. So you probably have used Nordic without realizing you've used Nordic. You've probably used a plethora of Nordic products without realizing they're Nordic products. Any given month, 30 to 40% of the qualified Bluetooth designs anywhere on the planet are actually Nordics. So what we're going to go through today is we're going to talk about kind of our different product offerings and go through the solution journey on how you can essentially, any concept you can imagine around an IoT solution, Nordic can get you from the absolute beginning of conception all the way to life cycle management for a full product development. So with Ground Supply, this is Nordic Semiconductor, and this is how we empower wireless innovation.
Hey, Johnny, I wonder if you need to be on the mic so that the
Oh, let me try. Hello. That's a bit shrill. I will try not to enunciate too heavily. Does that sound good or bad? Okay. So here's going to be the agenda for the talk. We already gave you a little bit of a Nordic intro. I'm not going to waste too much time on that. And we're going to walk through the solution journey from hardware offerings and all the things we solve, both short range, long range, and power. So when I say short range, I'm talking about things that are in the 2.4 gigahertz space. And when I talk about long range, I'm going to talk about cellular IoT, which if you've attended the workshop or puzzle hunt, you're already familiar with and well-versed, or if you've got a thingy somehow at the show because we gave out a ton, you're familiar with, as well as power. So a lot of our applications being IoT are also battery-powered. Not everything needs to be line-powered, and so we also decided to bring out our own power solution. Next, we're going to move on to the software solutions that we offer because a lot of people who are creating this thing also need a good unified way and good tool set to be able to just write an application and not constantly fight the battle of software and porting and moving around. And also we have cloud services because, quick question, how many people have worked with AWS IoT Core? How many of you have gotten accidental bills as a developer? Yeah, that's definitely not the experience with our cloud service. So we're very developer friendly and developer centric, and I'm very privy to Nordic Cloud. So we'll talk a little bit about our cloud service offerings. And lastly, we'll do some closings with some cool honorable mentions on open source projects that are, have Nordic in them and all the good Nordic secret sauce, as well as Q&A. So we could go a little bit deeper if you guys want to in any of the subjects that I briefly touch on. So a little bit about Nordic intro, more specifically an intro with me. Who am I? I'm Johnny Nguyen. I'm the field application engineer for the Pacific Northwest at Nordic Semiconductor. But prior to Nordic, I was the toucan on GitHub. I contributed a lot to AVR Freaks and a myriad of open source projects, as well as Zephyr. And I was previously a Nordic customer. So I was actually a developer, developing products in your shoes. And I did the age-old exercise of, let me buy every single vendor product. Let me buy all their socks. I want to make something with it, right? I'm going to buy a Scilabs. I'm going to buy an ESP. I'm going to buy an ST. I'm going to buy a microchip. Bought everything available. And then almost 99% of the time, Nordic won in almost every category for me, from software sustainability, portability, support, time to market, time to development, power especially. Nordic almost consistently wins on power for any IoT design. The one thing sometimes Nordic didn't win was learning curve. That's usually the cost that I felt, is there's a lot to learn, right? So the parts are very capable, but a little more complex to use. Some examples of some of the things I've worked on that are, powered by Nordic that you guys have seen out there are these guys. If you've seen these guys in North America or Canada, the crosswalks, the school zones, the speed zones, I worked on the firmware on a lot of those radios, and a lot of them were enhanced by Nordic. I worked on a lot of the FLIR camera systems, as well as the machine learning you've seen that, can count the number of cars and dogs and pedestrians, as well as IoT 4AG, which is using IoT for agriculture grant. And I also work on a lot of open source projects. So this right here is a complete from scratch open source hardware and software handheld gaming platform. It's Wi-Fi capable. I wrote the RTOS for it because this was back when bare metal was more popular. And so I'm also been present in a lot of open source stuff, not only on this GitHub handle, but my old one. And so it's a little bit about myself. So Nordic Semiconductor, for those who are uninitiated, I'm just going to quickly gloss over that we pretty much dominate the IoT market for any kind of design as far as power, optimization, and ease of use. No one has ever had a bad experience with Nordic or our support system. I never did. I enjoyed the Nordic support system and their ecosystem so much, I joined Nordic, right? No one has ever been able to capture me that way. Even in my spare time, I would, trawl the dev zone and I would contribute as a non-Nordic employee. So we have solutions for pretty much any IoT vertical. We're always on the cutting edge of IoT verticals. If there's an incumbent technology that has a lot of infrastructure developing around it and will be powerful, 9 times out of 10, you're going to bet that Nordic is going to have the first solution out there. We basically will be able to take you from the hardware, from the ICs, to the software. We're going to give you all the SDKs, all the code, and functioning samples out of the box for you to adapt to as wide plethora of use cases that's as close to your product as you can. We have all the tools you need for our development, and we have cloud services. So this is a good picture that we're going to come back to a lot. It's essentially a portfolio summary of all the stuff Nordic provides. And we're going to come back to this slide so we can focus in and dial in on what we have and some example applications from each of these to give you an idea of the types of things you can make. So at the end of the show, when you start to think of a wireless design, the first thing that would be great for you to pop into your mind would be like, yeah, Nordic's got something for that. And probably, oh, I've worked on Bluetooth before. Nordic has cellular. That code is really easy to understand and move around. So there's a level of expansion there. Maybe you've worked on a Bluetooth or a Zigbee or a Thread device, and you want to branch into cellular or Wi-Fi, or the other way around. So Nordic gives you that ecosystem to kind of develop any IoT product you want. So I'm going to kind of walk through that developer solution journey and show that how you can have a full package solution. So we have all the technologies, we have all the certified stacks, robust, tested, on top of certification, so you guys can reuse certification and minimize your time to market. And that's a really big deal. Anything from Bluetooth to Thread to NB-IoT and LTE-M, so you could do both on the 9160 or 91 series, Wi-Fi, and NR+, which is a new and incumbent technology, which is like 1.9 gigahertz. And there's some advantages to NR+ that kind of, it's a good way to look at it is it's a gap in the IoT market, and we'll touch on it when we focus in on that technology vertical. Moving up in the OSI layers, we got application support for Matter, Amazon Sidewalk, Apple Find My, and we also have Google Find My support. So you could do it all on all our products. And we have integration into a lot of tier 1 ecosystems that maybe you're a smaller company, maybe you're a startup, maybe you're trying to do a crowd supply project and you want to get into these ecosystems, but no one from these tier 1 organizations will talk to you. Well, they talk to Nordic, and Nordic never doesn't talk to anyone. We don't ask about volumes. We don't ask about, how much are you going to make? We just say, what are you making? Oh, that's really, really cool. We'll help you out. So we have a lot of enthusiasm around that. And they'll talk to us because we have such a large market share on all the IoT technologies, so we kind of give you that entry point. So how does Nordic address the developer to device journey? You're going to start off looking for parts. You're going to go on Octopart or DigiKey or something, and you're going to type in Bluetooth SoC, Bluetooth MCU. And you're going to start scrolling and scrolling, and maybe you'll find Nordic. And I think it's a shame that on a lot of those lists, you can't advertise all this, right? You don't know that you have all of these things for your development life. So you're going to start off picking the part, and then this is going to be the pain point for everyone. Nobody ever really does it perfectly. I think Nordic, out of all the ones I've tried within the last 5 years, and even though I work at Nordic, I always buy other products, and I'll say, I want to do this same project on a competitor part and see how easy it is. And this battle.
Just a quick comment. Johnny, up until a year ago, was on your guys' side of the desk. He was a developer. We stole him out of one of our customers. So when he says he's used them, it's valid.
Yeah. So yeah, Nordic honestly has the easiest fight here. I mean, we don't even have an Eclipse-based IDE. We're a Visual Studio Code extension. How many of you like Eclipse? Because I certainly don't, and I've seen it crash. I don't like Eclipse. I don't like Kyle. I definitely don't like IAR. I like Visual Studio Code and GCC, though. I'm a big fan of that. Ecosystem. I cannot begin enough to emphasize how awesome the developer community is for Nordic. The Zephyr Discord, for example, we'll talk about Zephyr later. All of the communities around Nordic and IoT, even in Arduino, right? There's a lot of Arduino BLE devices and libraries that are built on top of Nordic. So we have an amazing ecosystem. We also have partner programs. Maybe you have an amazing software team and you don't have any staff for hardware and you need to get some hardware work done. We have solution partners. Or the other way around, maybe you have an excellent hardware team, you have a Nordic design, but you need just some code for it. We have partner programs. So we can actually connect you with some of the people you need to get that product to market, to get it working. And lastly, we have out-of-the-box integration. You are not ever going to find something and be like, I want to connect this to my iPhone and pass data. It's just going to work. It just works. So if any of you pass by the Nordic table and you saw that Bluetooth screen and it connects to an iOS phone just fine, that was 10 minutes of work. 99% of the work was already done by Nordic. The most time-consuming part was deciding where I was going to put the text, right? The graphics library was done. Putting in an image, no problem. Getting Bluetooth, a solved problem. So most of your development time is going to be spent there. Most of your focus is going to be spent on making your product and not trying to fight an already solved problem, which is a huge problem with a lot of vendors. You get to an end device and then you want to go to lifestyle services, right? Or life cycle services. So I need to do firmware updates. I need to do fleet management. My company started with 100, maybe 200 of a unit. Now I'm selling 10,000 a year. I've been on that end. Now I need to do cloud services. I need to create an S3 bucket. Okay, I need to do an Amazon account and do all these things. And it's a little bit of a disaster. The Nordic Cloud has some of the best, absolute best device management I've seen on all cloud service providers. Not biased. I genuinely, when I was a customer, wish Nordic Cloud was available. So our priority is for longevity, not just for your development life cycle, but we want to make sure that you have an awesome steady stream of revenue on your product, and you can keep it going and keep the customers engaged and deliver a security update if you need to without trying to argue with a larger company. So these are a lot of the ways we deliver on developer experience. I should probably have put Crowd Supply somewhere in here, but we have the Dev Academy, so that's basically free open courseware. All the code is available. If you've been to the workshop, it essentially was a developer academy just for a specific use case, which was the puzzle hunt. That will teach you everything from Zephyr to Wi-Fi to Bluetooth to cellular and beyond, bootloaders and everything. The Dev Zone is one of the most amazing communities I've ever met. And one of the first things I did at Nordic was I went to all the Dev Zone engineers that I talked to before I was at Nordic and said, hello, I am here now. Genuinely some of the most amazing people and gifted people ever, and they are on your side. They care mostly about making your product work.
One thing I want to add to that real quick is the Dev Zone is not where we stop our interns. A lot of times on web-based communities, things like that, that's where some of our competitors stop the interns. These are seasoned professionals that have direct access to our R&D teams and our silicon designers. What? Oh. Yes. So, yeah, our people on the other end of the Dev Zone are strong engineers that know our product.
Absolutely. And and they do everything from software support to if you want to make a private ticket and it's only between you and us, we look at your schematic even. We have people who are excellent hardware engineers who you say, hey, did I follow the instructions correctly? Just please sanity check that I did everything. And 9 times out of 10, you will miss something. It's better to find out and get a second pair of eyes that, is part of the vendor than to have your EVT or your PVT come through and have to do another board spin. That's weeks of development time, right? For, oops, I shorted a cap here, or I forgot a cap, or I forgot a matching network component. We have the tech webinars. If you've never followed Nordic webinars, I highly recommend them. Even if you're never going to use Nordic, follow the webinars, because the webinars teach you about universal technology information. If you want to learn about LE audio, for example, and those of you who don't know what LE audio is, do look at our webinar on LE audio, because classic Bluetooth audio is going to be deprecated. There's a tech webinar. Maybe you don't have to use Nordic, but the technology is still relevant and valid, and you're going to learn something new. And lastly, we do Nordic Tech Tour, which is a little bit similar to this, and we're going to have lots of workshops on the tech tours, lots of activity. Try to go to Tech Tour if you can. It's an awesome experience. So I said we're going to come back to the slide a lot, and we're going to key in on a few things. So next I want to focus on multi-protocol. A lot of people know Nordic for BLE, but they won't remember us for Zigbee or ANT even, or Matter, or Thread, or proprietary, right? Maybe BLE is too slow. Maybe you need to go really, really fast. Nordic is the fastest, period. If you have any high-speed wireless applications that you want to be in the 2.4 space, we pretty much have the best options for that. So the NRF52 series is probably the broadest range of portfolio. You have a lot of memory options, a lot of I/O options for a wide set of applications. Everything from I need to create something for a maintenance worker and I need a wire replacement because I don't want them to use a cherry picker to connect this long wire to something, all the way to I want to make a mouse or a keyboard or something with high fidelity, high speed that's not actually battery powered. So both of those can be accomplished with the 52 series. 52 series has one of the best, and it's actually a pretty old part, but has one of the best multi-protocol radios around. It's got awesome start and stop times. It can actually support up to Bluetooth 5.4. And there's security. The security story starts to become increasingly important every single year. We're starting to see NIST have new requirements and certifications around security. So I used to be a member of the Wisconsin IoT Council, and I met with NIST there. Even the US government is starting to have new firmware security like recommendations. So security has always been a big deal at Nordic, and this has security features in it. It has a secure memory protection, and it has code protection. And an abundance of GPIO. Like if you could do a keyboard, you could probably control most of what you're trying to do. One of the other cool things about our devices that's universal to all of them is something called PPI. If you guys have never used PPI, it's probably one of the coolest things about Nordic. If you don't care about the radio, there's plenty of people who use our SoCs just for PPI. The easy way to think of PPI is it's a way to connect hardware peripherals together and have a task, trigger an event with no CPU involvement. You can have your CPU doing something more important that requires deterministic attention, but maybe I need to toggle a GPIO based on my radio. You can use that with PPI, right? Or maybe I need to have a timer start a PWM sequence for this really weird sensor and the vendor never changed the startup sequence and no standard peripheral supports it. But I need my CPU, so I can't bit bang it. PPI. Here's some cool use cases and applications for the 52 series. Tons of medical wearables that you see around are going to be based on 52 or 53. It's actually fast enough both on a soft, like the MCU, and on the radio to do VR, right? As well as ear-worn pulse auxes, smart plugs, smart hubs, mice, keyboard, right? BLE sniffers. Everyone who's gotten a lunchbox, you've gotten a BLE sniffer. So the 52 can really fit a wide range, and you pretty much just pick which one has the requirements you need. After the 52, we kind of had a big brother to the 52 because people wanted more. We needed an even stronger radio. Maybe you wanted a completely standalone application MCU. Maybe you want to do machine learning, right? Maybe you want to run some kind of inferencing on a sensor, but you don't want to stop your machine learning inferencing to do Bluetooth. The 53 is a superset of the 52, and it's our first short-range dual-core device. On top of improved security, it also has better power and more memory and 2 cores. It has a standalone network core and has an application core. So one of the really cool things about the 53 is it has an audio PLL for LE audio. We're one of the few people you can get right now and make an LE audio solution. One of the other really, really nice things about the 5340, as I said, was that standalone application core that you can use. So one of the really, really nice applications that I made for that was a machine learning application for wake word detection. It was kind of a really simple thing. I wanted a stimulant response type of thing. I wanted to say a word and send a notification to my phone. That's a pretty normal thing to want to do. But what if I want to change the word? Classically, before any kind of machine learning, you'd have to analyze the phonemes and then constantly sample and break down every single piece of the audio and hope that you matched your time slicing just right to action on it. Instead, when you use machine learning, you simply just provide it with a proper data set, generate your neural network, localize it, pass it over, and just have the ARM core, the application core here, just running inferencing all the time, right? And so you don't want to interrupt that to do Bluetooth when you need to. So that was a really cool thing. I got down to 70 milliseconds of inferencing time on voice to be able to send something over BLE. That was an out-of-the-box tool, yeah. So one of the other things that we recently offered that's not in the slides is Nordic Machine Learning Studio. So if any of you are familiar with TensorFlow, Machine Learning Studio is essentially TensorFlow Lite wrapped up and easily integrated into our SDK. You can either do your Python scripting like you're used to, or you could use the GUI and just do all your training data, and it'll deploy a small-scale neural network with TensorFlow Lite, so you could deploy it into the SDK and run your inferencing through it. Your application code will stay the same across all your models as long as it's the same type of model. So maybe you start off wanting to do a type of inferencing on ECG data or something, but now you want to move to vibrations, right? The type of inferencing you do in the application will be the same. Your code's going to be the same. You just retrain a model and deploy it, as long as it's the same type of inferencing. Yeah, works out of the box, really cool thing. Honestly, it seems like a monumental feat to have gotten that working. I got that working in a day, and that's not necessarily because I'm smart. It's just because the tooling is amazing. I'm sure Nordic Machine Learning Studio. So yeah, a lot of the times, I mean, everybody's felt that sunk cost of poor development tools, or maybe there's something really weird and it's inconvenient to get to where I want to go. Well, we don't necessarily have that. So Nordic, always innovating, always going for the next step. We made a big brother to the 53, which is the 54. If you don't walk away with like anything else from this presentation or show or our demos, I want you to remember the 54, right? The NRF54 series is the next generation of wireless multi-protocol radios. It's not just, I wouldn't just think of it as a radio though, it's just a really, really sweet SoC. You could think of it as a really nice MCU with a radio that happens to be there. So the 54 is essentially a really kind of ballpark number to think of, is you're going to be able to do anything you do on the 52 today, which is already extremely low power, with about an 11th of the active power. On top of that, we have a 4th generation of Nordic radio. So every single time, one of the most common questions I'll see is like from the Nordic side, and one of the most common questions I had as a developer was range and throughput, right? One of the biggest contributing factors to suffering on range or throughput is receive sensitivity. For example, I want to go up to 2 meg PHY. What happens to my receive sensitivity? Clobbered, right? I want to use 2 meg PHY with USB plugged in. Receive sensitivity is clobbered. Or maybe I want to use coded PHY, and I'm starting to get a signal dropout. First thing I ask, what was the RSSI towards the dropout? And it's almost always, when you track it down, receive sensitivity. The receive sensitivity on the 54 goes down to like negative 100 dBm. Most radios you'll see that weren't Nordic will go to like negative 80. Ours, previous generation radio, would still go to 90. So we pushed it even further. The active power being lower is a really big deal because as time goes on, more and more people want to run a basic inferencing because there's a ton of value in it, right? Instead of constantly trying to math out slices of sensor data, I'd rather just funnel it into a local neural network, right? So having an 11th of the active power will be a boon in those situations. You're going to have a 4-month battery application that now extends well beyond a year. And it's still going to support all the same wireless protocols as before, and then some. The last thing I want to note about the 54 on this page is the 4 meg throughput. So you remember I said you could get really, really fast with Nordic radios if you step out of the realm of BLE. We also go to a 4 meg PHY on that. So in ideas of order magnitude, the fastest BLE can go, or Bluetooth 5 can go, is 7.5 milliseconds on the connection interval. That's as fast as you get. BLE audio, the fastest you get on average is 5 on an ISO channels interval. ESB on our previous generation radio can get down to hundreds of microseconds or less. And this is going to be even faster. What's ESB? ESB is the proprietary Nordic high-speed mode for wireless communications. It's called enhanced shock burst. Or you always have direct access to the radio if you want to do something yourself, right? So at a glance, there's going to be 2 54s at the end of this year. There's an H and an L. There's a high end and a low end is a good way of thinking of it. By no means does that mean this is a low end chip. It just means this one has less stuff in it. The high end one is an absolute kitchen sink with 2 ARM cores, 1 secure core that you don't necessarily have access to, and 2 RISC coprocessors. It's a 5-core device. Has 2 megs of flash and 1 meg of RAM. That is an insane, for anyone who's done embedded development, that is the most ridiculous amount of RAM I've seen in a long time on a tiny SoC. You've got an overabundance of I/O, 64 GPIO on the 54H, and you have advanced peripherals, including I3C. How many people are familiar with I3C? How many people are familiar with I2C? I3C is I2C faster. All you really got to worry about. The RISC coprocessors are pretty gnarly because the nice way to think of them is they're really just a scratch pad for you to do whatever you want. Maybe you want to add like transaction information, so you need to implement that ISO serial standard. But all the SoCs you're looking at don't really have it, and you don't want to have to bother Broadcom or Qualcomm for something. Just bit-bang it on the RISC core. It's just there for your use, right? Lastly, security. So as I've been saying, the security story is more important. Both of these devices are PSA certified level 3. How many of you are familiar with PSA certification? So PSA certification is basically a security requirement, and the real kind of TLDR takeaways are level 2, software protection, level 3, hardware protection. So really recently there was a casino that got hacked because they looked at like the voltage domain on one of the wireless devices and were able to fish out a cert, right? So preventing side channel attacks is something that PSA certified level 3 devices have to be able to do. And lastly, there's a couple of different stats on the radio. So the 54L has a little bit less performance on the radio than the H, but honestly, truthfully, you're still going to have miles above any other short-range SoC using the 54L. So I kind of wouldn't really pay that any mind. And if you're, if you really need to go between 8 and 10 dBm on the output power at that point, I'm pretty sure everyone's just going to slap a FEM on it, or a front-end module. So, you know, although there's some differences in the radios, I kind of wouldn't pay it any mind. All of them are 4th-gen radios. And in the spirit of crowd supply and open source hardware, for those of you who don't know, RISC is a royalty and license-free instruction set architecture. So Nordic is really big on open source, and we'll kind of hit that towards the end of the presentation. But that's one of the nice highlights for crowd supply is that we have RISC cores in our new devices now. So, like I said earlier, please think of them as amazing chips with radios attached. So if any of you are familiar with CoreMark efficiency or anything like that, we're the yeah. Oh, okay. Sorry about that. So we're pretty much top of the charts on CoreMark if you're familiar with it, and it's on a tiny sock. So the L15 can be down at 2.4 by 2.2 millimeters. I tried to get a scale image there, but it's getting blown up on the TV, so I don't think you can see it. But I'll show you guys after if you guys want to see. I have a business card with some of the sizes on our similar components. And on top of that, you're going to have the best radio performance. I'm going to emphasize that out of anything. It's going to blow the water out of any competition. Some ideas on target applications. These are not all the applications. I'm sure like if you've got some thought bubbles around what you can make around this device, these are just some examples. On the L, you can make any kind of PC accessory, any kind of gaming or media controllers, smart home devices, medical devices, industrial IoT. Anything you could do on a 52, you can do better on a 54L. 54H will be something like for really advanced. Maybe you need to do a large display that also does safety critical concurrent controls, right? Maybe you want to feed it to a PID controller or something. Maybe you need, instead of a class 2 medical device, you want to move up to a class 3 medical device and you need guaranteed determinism, right? LE audio, since it'll have the PLL and higher speeds, as well as e-mobility. The 54H is a really, really good example on like, I need a very, very powerful device, but I don't want to step up to a SOM and have to worry about my build distribution and stuff like that, or the huge power hits that come. Before, when I was a Nordic customer, I kind of did the exercise of using a SOC versus a SOM because I'm a big fan of Linux and I'm a big fan of doing Linux user space applications for the reusability. And the ambient power for SOMs is actually quite high, right? It's in like the order of milliamps. So for battery powered things, that's kind of not a great thing. So this is kind of the solution to, I need the capabilities of a SOM. Maybe I don't need the radio, but I absolutely have to be on a battery. So back to the original slide. So we've kind of made it out of the valley of the multi-protocol, and I'm going to focus on the next key technology vertical. So next up, we have the cellular IoT. How many of you went to the workshop? Okay. How many have a thingy? Okay. If you do not have a thingy or went to the workshop, but you want to do some kind of cellular development, just talk to me afterwards, because there's a lot of really cool use cases and applications around that. So kind of here's the landscape of like LP WANs. You got your deprecated cell phones. You have your cellular LTE-Ms or LTE Cat 1s, your 4Gs and your 5Gs. These used to be really, really popular because we didn't have any other infrastructure around for IoT. So a lot of old IoT devices, it was really hard for smaller companies to get started because you basically had to slap a cell phone into everything, which was expensive for the device. And then you had the data plan of a cell phone for every single thing you deployed, which was a disaster. Then you have the sub-gig world, and the sub-gig world is fun, and I have a million bad things to say about it. I have a few good things to say, but a million bad things to say about it, so we'll kind of gloss over that. And then we'll kind of go to the cellular IoT domain that Nordic focused on, which is LTE-M and NB-IoT. So the huge boon of LTE-M and NB-IoT is these aren't cell phones. We don't need voice. We don't need high-speed audio streaming. We need the occasional photo. We need sensor data. I don't need to send somebody out 200 miles into a remote location to collect some kind of information. I should be able to put something there. But I'm not hosting a call with a tree or a gas pipeline or something, right? So that's kind of where the Nordic cellular devices fit in. And a lot of times you'll hear information from maybe 15 years ago of, oh, the coverage isn't that good, or you won't be able to have good connection and the thing's going to drop out all the time. Here's basically a global cellular IoT coverage and trend map. So I don't know a lot of people that are deploying in the middle of the Sahara, and I don't know a lot of these strange niche edge cases, but most of the time you're going to have good coverage in LTE-M. So the 9160 is kind of Nordic's answer for that. And every single thingy or dev kit that you've had from the workshop is with the 9160. And the 9160, I'm a big fan of the 9160, and we'll kind of go into why, but it's a ARM Cortex-M33 application processor built in, along with a multi-band LTE NB-IoT radio that can also support GPS. So you don't have to sit there and say, oh my God, I need to figure out where the thing is. Let me go buy a standalone IC for GPS. That's integrated along with the modem, along with an application core, all in a small form factor with the PMICs and passives to save on board space, as well as to help with certification. On the market, the 91 series is the lowest power cellular IoT device you can find. And here's a fun fact. If you walk away with the idea of low power, a lot of the times a Nordic cellular IoT application can outlast the battery chemistry on your product. So the floor current here for power save mode is 2.7 microamps. So what's the difference between like power save mode and quiescent current? Anyone know? So power save mode is basically a low power state that you go into in a cellular connection, but you still are going to have to wake up to page. The quiescent current is basically I'm in like a very powered off mode, just RAM retention kind of situation, plus like, you know, the other PMICs and passives. That actually gets lower than 2.7 microamps on this device. And we have development hardware all over the show, as well as you can get it online, which is the Thingy 91 and the NRF 9160 DK. So if you received any of those, then you'll be able to develop cellular IoT applications. I've developed kind of numerous cellular IoT applications, both 4G and LTE-M. This model is everywhere. You'll see it all over the place. You can go try to buy some kind of IoT gateway and crack it open. You're going to see this all the time. You've got an MCU from one company, PMICs from another, security elements because these are connected to the cloud, so you need certs. And then 9 times out of 10, they'll have Bluetooth, so there'll be a company XYZW, whatever the other missing letter is. And then the modem module, right? So what does that mean is you're going to have to get this vendor library. You're going to have to put it in, try to wrestle it into your application and figure out where you can put the vendor library modem calls in your code to try to pull data out. What Nordic does is we consolidate it all into one device. So you're not going to be trying to wrangle any vendor library. It's all integrated. Maybe you have an existing solution and you want to add cellular IoT. Don't change your code. Just take your serial protocol and put it in the application core of our 9160. You essentially never changed your original code or product. You just added something for it to talk to. That's the ideal use case. That's what we all want to do for cellular IoT. The 9160 is the only thing I've ever found as a customer that can do that. And even now as a supplier, I look around and I'm still not seeing people do it, which is a shame because this is a disaster. How many of you like 5 tool chains installed on your computer and change your build steps every single time? 5 different sets of data sheets. So I have a folder for Nordic, and then I have a folder for ESP, and then I have a folder for ST, and then there's the one for U-Blocks. It's honestly a really difficult thing to do. The other thing is it kind of simplifies your cost in a lot of ways, right? Instead of having to negotiate 5 or 6 different prices, you're just like, I'm just going to buy the one thing. It does everything I need. I don't want to have to look for all this extra stuff. So it's honestly a really mature part. It's not really new. It's been in the market for several years now. And lastly, it's globally certified. That's a big deal. So we've certified our device and done a lot of testing, and you can reuse a lot of that information to accelerate getting your product out there, right? And we also have module partners, so you can buy pre-certified modules to skip even more of the work. You still have to certify your device with the carrier, but a lot of the other certifications you can inherit from that module. So here's kind of the line card of what you guys saw today and what's, you know, incumbent and coming out. So the 9160 can do all the cellular IoT stuff today. Any of the 91X1 series can also do DECT, which is a 1.9 gigahertz low, not really low power, but wide area mesh that can support high device density and higher throughputs. So I have a couple of slides coming up on DECT, and we'll go into a little bit more detail there. The 9151 is actually smaller and is going to be lower cost. And if you have any security concerns, it's undergone a global diversification strategy. So if you've ever seen any other modems appear in front of Congress for security, that was kind of a big motivation for 9151. That's not going to happen with that. So to kind of summarize all of the components and like all of the X or A through F modules, the 91 SIPs come with all of the components, including the PMICs. The PMICs, passives, crystals, RF front end, application core, and modem. So how many of you are familiar with AT commands? You're not going to be writing AT commands. You're going to be making calls to an AT library the way that should be done. That's the correct way to do things. You're not going to be sitting here trying to be like, okay, create a state machine to receive the response from this AT command to decide which one to do next. You don't have to do that anymore with ours. And to give you an idea of why I hate data sheets, this is a little slide. It's not said explicitly here, but this is a huge reason why I hate data sheets. On paper, module X, so this was actually a measured thing, has a lower PSM floor current than our device by 50%. You'd imagine it's a better device for power, right? Because how many of you have gone through the exercise where you pull up the data sheet, you go to current consumption for every single one, and then you just say, pick the lowest one. I've done that a million times. I'm sure a lot of people do, right? You'd think it's the highest ROI way of finding the lowest power device. Unfortunately, people don't sit down and put in the extra time to test how much the actual application power consumption is. So with this module X that's supposed to be 50% lower power, it doesn't last anywhere near as long as our device. At different PSM intervals, so just to refresh on what PSM was, it's like an interval where you can stay asleep as a modem but maintain the connection to the base station. At some intervals, it'll have 10 times longer battery life. And they only diverge towards the higher, longer sleep period on intervals because it had 50% lower sleep current. But for this example, even all the way trending downward as high as you can go on PSM intervals, we still 7 times longer on battery life, right? Because we actually sit down and take the average and we think about, we want this device to be out there and no one's going to touch it for years. Nordic's kind of your only really answer to do that today. And then here's the bonus about DECT. How many of you have heard of DECT before today? That's surprising. Okay. Usually no one ever hears of it. So essentially, a way to think of it is your cordless phones, right? So you know your parents' cordless phones, and so we're reusing that ISM band for DECT. So it's very, very high speed in the sense and low latency for voice. It's still capable of that. But it has better penetrative and range properties than 2.4 gig, right? So maybe you want to do an outdoor application and there's shrubbery. Shrubbery is just a giant bag of water that's the bane of 2.4 applications. So DECT has better penetrative properties. The other thing, if you remember earlier in this talk, we talked about receive sensitivity. One of the biggest contributors to damaging receive sensitivity is the noise floor. All of you are carrying 2.4 gigahertz radios around you right now. So, for example, something that Bluetooth does to support the device density is that there's a randomized delay between all of the radio activity. So there's a better guarantee that you won't collide with each other. DECT is pretty much silent, like dead silent noise floor. So on top of having higher data rates, the noise floor is so low that you can receive things really well. It fills kind of that gap of, I need to connect a lot of devices, but longer range, but I need the speed of 2.4. And you can deploy it globally without having to change your SKU for every single geographical region, right? And so here's a world map of all the places you could deploy a DECT solution without worrying about any kind of certification problems in that way. You still need to certify yourself as an intentional radiator. Didn't say you don't, but you don't have to deal with a lot of the regulatory headache in all these regions. So some of the features of DECT I'll kind of quickly go over is it's a mesh network, so it's self-healing. Maybe something drops out and you want something else to pop back in. It's decentralized, which is one of the biggest advantages of a mesh network, right? So all the star networks, when someone takes out the head of the star, your whole system's offline. by being decentralized, you can afford to lose a thing or two, get an alert that something's missing and replace it. It's ultra low latency because it originally was used for voice and phones. And it's highly scalable thanks to the noise floor and the technologies and the modulation. So the amount of device density you can have is insanely high. You can have a square kilometer covered by 100 nodes up to 1 million. So some ideas of applications to get the idea, the wheels turning on. What can I use this for? Large factories, warehouses, smart buildings. Maybe you want to track assets with like a localized network. You don't want to trust having to deal with cellular IoT, right? Electricity metering or water metering. Smart street lighting, parking, traffic management, bin collection. Also another one is agriculture, right? So we're trying to continuously increase agriculture processes all the time, make them more efficient, save the planet, woohoo. So that's a really good use case to kind of penetrate through the vegetation. And so for some ideas on existing designs that are out there with the 9160, my favorite one is probably this cellular tracking bird tracker. So it's a little backpack that goes on a bird that has a solar panel on it. So the 9160, you can actually build a fully working tracking device that's a backpack for a bird that doesn't die, which is phenomenal in my opinion. There's a lot of... Hopefully neither. But, in the spirit of the device will outlast the chemistry, it may outlast the bird too. As well as like wearables, trackers. There's more and more wearables that are cellular capable every single day. All your smartwatches tend to be cellular capable, and you need the small form factor. And, users absolutely hate needing to charge their thing often. So the more power you can save, the better.
Johnny, I think we got about probably 10 more minutes and we're going to lose this crew. Let's jump into some of the tools and the ease of use and stuff like that.
Sure. Boop, 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 boop. So...
While you're flipping through there, just so you guys know, it doesn't take a lot of brain surgery to figure out that, okay, we've got the Bluetooth today, we've got Wi-Fi today, we've got cellular today. Putting the almonds, the chocolate, and the peanut butter together in one delicious candy bar, probably not too far off in the future, right? So that'll all be based around the NR54. So if you guys start developing around 53, 54 on the NR Connect toolchain, making that migration is going to be super simple.
Right. So skipping ahead to kind of the software side of things, so away from the devices. So in the spirit of open source, all of our code and samples are open source. All of our drivers are open source. Our mobile applications for debugging Bluetooth applications are open source. So everything you could possibly need for developing a wireless application, Nordic has from a software perspective. One of the important things that I want to highlight is essentially the technologies and tools. So I've had some discussions, throughout the show where there's not a lot of vendors that have SDKs that are well suited for CI/CD. They're really well suited for creating an application and sending some image to your production facility, and then that simply is it. But maybe you want to do a firmware change that results in a rolling update throughout a country, right? So our toolchain is designed with CI/CD in mind because that's something we follow. Our IDE does not force you into Eclipse. It's a Visual Studio Code extension. And lastly, we have a huge commitment to Zephyr. So how many of you are familiar with Zephyr? How many are familiar with FreeRTOS? Okay, so Zephyr is kind of an RTOS, well no, not kind of. Zephyr is an RTOS that span up from the Linux Foundation that's open source, and it's not going to be beholden to anybody. It's not going to really belong or get acquired like FreeRTOS did with Amazon. And as of right now, it's the only RTOS I've seen that's actually hardware agnostic, right? So why does that matter? will give you an anecdotal story. So a couple years ago, there was a part shortage, and the part shortage sucked, right? Nobody liked the part shortage. So I had to port, I think like 7 different devices and wound up having 6 different versions of things. All of my Zephyr Nordic-based ports took less than a day, which looked really cool to my manager. But it took less than a day because it's designed to be hardware agnostic. I didn't change my code. I just changed the build. So that's kind of one of the really, really powerful things about Zephyr. It's also designed to be low power. So all other RTOSs are, usually have a sysdig handler that wakes up with a system clock, and then the scheduler needs to, decide what to do next. Zephyr is instead event driven. And so you can actually hit these really, really low power states And that's one of the reasons we made a commitment to Zephyr. It's developed with a focus on security, and it includes a ton of functionality so that Nordic can kind of keep developing the latest standards certified stacks for all the wireless protocols. One of the other important pieces of Zephyr is that it's open source, and that's super important to me, and I think to Crowd Supply in general for being an open source project.
Just to highlight some of that as well, like you're starting to see Renaissance jump on board, NXP jump on board, TI is jumping on board. Multiple silicon vendors are finally joining what we've started 5 years ago. So, you know, it's not just a Nordic thing. This is multiple silicon vendors are hopping on, which then goes back to Johnny's earlier comment about it being agnostic, right? So, if for some reason you no longer fall in love with Nordic and you want to use somebody else's SoC, your code's very, very important.
Right. Another note that I'd like to make is there's kind of a common misconception that an RTOS is going to be super bloated and require more memory. In Zephyr, because of the unique way it kind of handles the build system and what to include, for some Bluetooth applications, it actually takes less memory in Zephyr than it does on a bare metal implementation. So we ran that memory analysis with our old SDK, as well as with Zephyr. It maybe will take a kilobyte or two more of RAM, but it'll actually take several kilobytes less of flash on top of all the other benefits you'll get.
Bare metal's great if you're blinking an LED.
Yeah. In a vacuum, your bare metal will always look good. I'm going to directly write to a register every single cycle. Yeah, that's like a couple lines of disassembly. And in RTOS, you have to include all the other stuff. But how many of you are creating a design or project or product where all you do is blink an LED? It almost never happens. When you add in connectivity, you're going to blow your memory budget on a bare metal solution most of the time. Zephyr has a really active community on GitHub. I'm definitely on it all the time, you know, going through pull requests or trying to get a device driver in. Nordic is a Zephyr Platinum member, and we've been a member and contributor since 2016, along with all these companies. So there's a large movement and adoption of Zephyr. Every time someone says, this standard is going to be the new greatest thing, everyone keeps saying stuff like that, but Zephyr actually consistently sees growth every single year. So the NRF Connect SDK for development, if you weren't in the workshop, is just a Visual Studio Code extension, and you absolutely do not have to use it. If you like CLI, stay in CLI. If you don't like Visual Studio Code, use whatever code editor you want. You never have to actually use the extension. It's just a convenient way to get everything in one place. So how does, kind of a quick dive into how Zephyr accomplishes the hardware agnosticism is, how many of you have developed Linux applications before in C? Right, so in Linux, there's this idea of user space and kernel space. And most of your applications are in user space. Zephyr, kind of coming from the Linux Foundation, employed the same idea. All the hardware dependencies are just devices. That's going to be separated from your actual application. The benefit of that is when you write an application, you don't change it when you change devices. The application's the same. I can make a Bluetooth application right now for a Nordic device and move it over to a WB55 if it supports it. To a non-Nordic one. Doesn't matter, right? So the code base is essentially, Nordic supplies all the blue stuff here. So all of the applications and samples that you get from Nordic, all of the connectivity protocols, and all of the wireless stacks we're going to supply. And then Zephyr includes all of the glue logic in between, right? So the huge benefit of this is this can change from vendor to vendor, but most of your application doesn't have to think about this. All you really focus on is your user space application at the top. Everything else is separated. I can switch SDKs. I can switch Zephyr versions. Most of it should remain unchanged from an actual code perspective, right? So like a good way to think of that is how many of you wrote that weird geometry calculator when you were first learning programming? The idea with Zephyr is that geometry calculator or that basic application is going to live across all of the versions. Like as you go further out, devices get more advanced. How many of you have like made a really, really cool project and maybe it was like 5 or 6 years ago and you're like, I really need this code. And you try to build it with the current version of the tools and it absolutely does not work. The code does not build, nothing works, you have 500 errors. That's not going to happen here, right? As long as you're on the right versions of things. All you'd really translate is a couple of configs and function calls and that's it. And lastly, kind of with the idea of managing source code and configurations and stuff like that, this is a really tangled way of saying all you're really worrying about is this. You're saying, I want to make all of these products. I want to have a way to abstract away all of these libraries, all of these code bases, and I want it to kind of funnel into different applications for different products I'm making. By moving over to Zephyr and the new SDK, a lot of people are like, I don't want to be forced into an RTOS. We did it specifically to reduce the bring up time when new things come out, right? Bluetooth creates a new standard. I need to buy a new device. I'm pissed off because I have to redo a ton of code or make new code. That's not really going to happen here. The only time you'll do new things is to make something new, and that's the emphasis, right? When the standard evolves, we want to focus on making something new, not rehashing old details. So that's kind of the software side of it. Lastly, closing. So I wanted to do a couple of open source mentions that are powered by Nordic. So the ZS watch is basically an open source hardware and software Zephyr powered watch, smartwatch. It uses the NR5340 and the NPM 1300. Those of you who aren't aware of the NPM 1300, it's a really, really slick 5-in-1 IC for battery management. The Healthy Pi Move, this will be kind of familiar because all your wearables are going to start following this paradigm. 5340, 1300 vital sign monitor. This is actually a crowd supply community hub project. And lastly, Nordic thingies and development kits. All of our thingies and all of our development kits files are open source. We provide you with an LTE-M project file. If you're a fan of KiCad, I'm a big fan of KiCad. KiCad has an awesome LTE-M project import. And we also, Nordic has created, one of our FAEs on my team actually made a completely open source entire repository of every single Nordic device in KiCad. Drag and drop. No work done on your part. So, you really don't want to sit there and look at the schematic page of a manual and try to figure out, did I do everything right? Just pull in the project and start making adjustments instead of something that you know that works, right? Another example of open source and really cool powered by Nordic stuff is NR52 desktop. We made a whole high-speed gaming mouse with the NR52 and keyboard example application from hardware to software. Maybe you want to make a keyboard. Go grab the reference design and make the adjustments and focus on what makes yours cool. Maybe you have a cool LED profiles. Maybe you're faster than everybody else. Maybe you have a better ergonomic idea, right? Grab the reference design and build from there.
That's actually a perfect highlight, Johnny, is our job is to make it really easy for you guys to do the connectivity, right? The secrets, the thing that makes your guys' product special is your application, your secret sauce, not whether or not it connects to a phone or not, right? That's not where you guys should be spending your time. It's fighting with the Bluetooth to try to get it to work. You guys should be spending time on your application and making your application special. And we'll make the rest of it.
And then if anything, you can harass the FAE and they'll get a lot of work. They'll get a lot of work done for you. Lastly, your lunchbox, if you got a lunchbox, came with a 52840 dongle. The barrier for entry for Bluetooth sniffers is very high. An LE6 cost a car. It's a disaster. A 52840 dongle is a Bluetooth sniffer. It's $9 usually, but all of you got one for free. So start working on Bluetooth applications. It's a really good time. And lastly, how many of you have played Doom? How many of you like the Doom test? Can it run Doom? The NRF52 can run Doom. We have a project for it. I don't know why you'd want it, but it exists. All right, so that's kind of the end. So if there are any terms anyone's unfamiliar with, or if you want to ask about a specific technology we mentioned, this is kind of open for Q&A. Also, thank you for your attention.
So I was wondering with the Zephyr HAL, or whatever you want to call it, and then all the cool things like this coprocessors and stuff, how do you differentiate when you're working against it?
Sure. So when you create a project, like you have the folder and there's a source with a main and all the other stuff you include. In our SDK, you literally click the core you care about and it pulls up its own files. So if you're doing any kind of inter-processor communication, you'd be implementing it there. But it literally is as simple as picking different projects and they just go into different cores. Or you can just leave them sitting and have them be in low power states. So I think.
So basically, you're happy with the way Zephyr just bubbles up the.
Yeah, especially when I used to work on dual core devices for TI, and you have to like wrangle with the claw to get interprocessor communication, and all the DSP is on this core, so I have to kind of manage synchronizing the two cores. Zephyr takes care of it in a really nice and elegant way. So the 5340 is like an existing device with products out there that is dual core, but from the developer perspective, the most you'll see is I'm just working on code in one and working on code in another using some shared memory domain. Any more questions? I did release them to Crowd Supply. I'm not sure if Crowd Supply is releasing them, but if you ever don't get your hands on them, just talk to me and I'll send them over. Anyone else? Good?
Thank you.
Thanks.